Hey everybody, back with another video. This is one of those times where I wasn't planning to film anything, but I started working on this G07 and then doing some interesting things, and then I was learning, so I figured might as well share what I'm learning, even if it's wrong. So again, warning to everybody who watches my videos, this is just me going through the journey. Hopefully it benefits you guys. If it doesn't, sorry about that. But anyway, here we go. I recapped this G07 monitor through, I think, what's his name? Arcade Parts, Peter, I think, or from Arcade Parts and Repair. I usually use his caps because I don't like buying a whole ton of caps on my own, and I don't do this enough to justify it. But I recapped it. And I had tested fuse, I think is this 901 or something. That's right here. I think this is 902. Yeah, this is 902. So I tested 901, and I could have swore it was fine. So maybe after I recapped it, it blew, but it's definitely dead now. So I pulled it. You can see there is no continuity on this cap. So that usually means, and before I capped it, like this cap right here was totally blown out. I think that's, what the hell is that? Damn, the glare is really bad. C905. There were several caps actually that were like atrocious looking, and I knew they were probably bad. So, and plus I got one extra cap, a 220 50 volt. That always freaks me out, and I have to scramble and think I missed capping something. But I'm pretty sure I did everything right. Put it back in. Nothing, I can hear it charge up and nothing happens. So I assume, either the hot or the flyback is bad. Or both, potentially. And what else did I want to say? Oh, the other thing is I watched one of Arcade Doc's videos on repairing a G07 as well. And this B plus cap, especially when this scenario, when fuse 901 blows, this thing will hold a charge. So I typically, or not typically, because actually as I was soldering it, the solder wire happened, as I was doing the cap kit, happened to bridge this and let out a giant spark. Freaked the shit out of me. But anyway, with this meter here, I can actually drain the voltage if I have any. Or you could just short it, or you could drain it. Like there's no voltage across this cap now. But I'll do this on another one too, just to see if there's any voltage. Okay. Alright, back to what this video is about. A lot of talking, sorry. So I wanted to break out, I want to test the hot, obviously, which is over here. I need to replace this fuse, and I pulled the flyback, and I'll be right back. Alright, so I'm just documenting what I've been doing. So I pulled the flyback, and I wanted to label it, what pins were what. It kind of shows you on the schematic, not as well, kind of shows you on the screen print of the PCB. But it, not perfect. So this is pin 10 over here. If I'm holding the flyback this way, G07, this is pin 10. I guess there's a 9, 8, 7, 6. This isn't labeled 5, 4, 3, 2, 1 like that. It's not labeled that way. This is labeled 5, 4, 3, 2, 1. But you can tell there's actually more positions if we count from on the clock in a clockwise fashion. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There could be actually 13 pins or, lugs on the transformer, I assume. But in the schematic or on the PCB, it's just labeled 1, 2, 3, 4, 5, 6, 7, 10. And I'll show you on here as well, if hopefully you can see it somewhat okay. So this is pin 1, 2, 3, 4, 5, 6, 7, 10. And you can kind of see the squiggly lines indicating the transformer portion of it, or the windings of the transformer. So pins like 4 and 5, if you can see that, 4 and 5 right there, are connected together basically. They're part of a winding. And then pin 3 and 1 are part of a winding. It goes woo, like that. So pin 3 and 1, 4 and 5, and then it looks like 6 and 10 and 7 might be like a center tap type of thing. I'm not sure. I'm not an expert again. But I know that this is kind of together. These are together. This is together. And I wasn't sure what 2 was. So then I look at the schematic, and that's even less you know, I don't know, forthcoming, I guess. I'm trying to think of the right word to say. But it does give me a little bit of a hint if I zoom in. Whoops. There we go. So we know this is our heater voltage. Hopefully you can see that, and it's somewhat clear. Let's see. Alright, that's, I guess, as good as it's going to get. So this is our heater voltage, and I just kind of traced it out, and I know that that's pin 6 and 7. Is it? No, I mean that's pin 4 and 5. Yeah, so this is pin 4 and 5. I assume this next one up here is 3 and 1. I'm not sure. And then the rest of this is probably, you know, your high voltage and focus wires are coming, you know, somewhere. Like there's your focus. It looks like it's kind of like a center tap, and your screen comes into that. You know, your high voltage, you know, anode is coming from this side too, but it's not really clear. Those don't go to any pins. They're just like in there somewhere. There's no pins correlating to those. The pin, I guess, is the anode, for example. So I saw this thing on YouTube that would show you how to test for which side is the primary side, and I think you can see it on the schematic here. The primary side of the flyback transformer is over here, and then it's the secondary side. We know the heater voltage is a secondary, you know, on the secondary side, so we kind of know that this is on the primary side. My assumption was 6, 7, and 10. Right there, 6, 7, and 10 were the primary, and these are all the secondaries, including, you know, the anode and the focus wire, which is over here. So you kind of get the idea. But let me show you real quick. I can get my meter out. Basically, what the video said is, and I did a video actually of testing a transformer in a Miss Pac-Man I might link to. I didn't go into this detail, but basically you should have very low ohms between, let me put my meter on ohms. There we go. Okay. You should have very low ohms between all of the secondaries. If you just go from pin to pin, you should be reading nothing. And then when on the primary side, you should get around like 1 ohms or 1.6 ohms or something like that. Right? So that's what led me to believe that this is the primary side. Now, to find out which part is ground on the secondary, you do this battery check. And I'll set that up and come right back. Alright, so we're going to take these two batteries, we're going to connect them together, put our meter on DC volts, and what do we get here between positive and negative? Like 17 volts. My leads are reversed. Alright, so that's 17 volts, and what we're going to do is we're going to hook up our negative lead to green, and connect that to the negative side of the battery, which is right here. And we're going to take our positive meter here and connect that to the anode cap, your high voltage thing. And then we're going to take our other lead and go to positive. And whenever, hopefully I'm doing this right, I'm going to touch these leads, and when I should get no voltage unless one of them's ground. So you can see there's no voltage there, no voltage there, no voltage there, no voltage, no voltage. Well, on pin 2, we get 2 volts. So we know that pin 2 is our ground on the secondary transformer side. So I thought that was interesting, and I wanted to share that because I didn't know what pin 2 was. I couldn't get any readings on my next test to it, and that's because it is ground. Alright? Okay, so I wanted to show that real quick, and I'll come right back. So we still don't know if our Flyback is actually good or not. I mean, I inspected it, and I don't see any cracks in the Flyback at all. There's no cracks. There's no black crap coming out of it. So I would assume that this is good, and I have nothing to tell me otherwise. Maybe it's the hot that's bad. I don't know. Maybe that fuse was blown. Oh, damn, I just thought of this. Maybe that fuse was blown before the cap kit, and I didn't realize it. And actually, all I need to do is put this Flyback in, and then the whole game will work. Maybe it was blown because of some caps or something. I don't know. Well, I'll have to keep that theory in the back of my head. Alright, but anyway, so what I wanted to do is then just come in and do some ohm tests and compare it to a known good Flyback. Now, I will make a comment on these Flybacks here. This one here, if you can see, the pins are jacked up. And I think I got this from Bob Roberts. Like, you can see pin 2 is not even the same length as the other pins, which is just dumb. I don't know what's going on there. This thing sucks. But this might have been from Bob Roberts. I'm not sure. It says T190R on both sides. T190R. Right there. Made in China. A2995. I think I got this from Bob. I have no idea, actually. I grabbed this one, and now I might have grabbed this from Peter at RK Parts and Repair. The pins definitely look much better. They're all of the correct length, at least. And this one says T1ZO or 0Q on one side, and then T190R on the other. Otherwise, I wouldn't be able to tell the difference between either one of these. So the T1ZOQ, that's one, and then I don't know what we're going to call the other one, but Bob. We'll just say that this one here is Bob's, and this one here is Peter's, but honestly, I have no idea. Okay, so I'm just going to do some ohm tests between pins 6 and 7. I know those are together. Very low ohms, 0 ohms, almost. Alright, 0.2. And between 6 and 10, 1.3. Now let me do the same thing on this one here. 0.8 on Bob's, but the same from 6 and 7. So this one has a little bit higher resistance on the primary winding side. This one is one I think is better, maybe from Peter. 0.8 So about the same, 0.2. Alright, now let's check a couple of the pairs on the secondary side. We'll go with the heater voltage, which is I think 4 and 5. Yeah, 4 and 5. .1. We'll go to 3 and 1. I'm getting good contact. 0.3. And I would expect to see those low numbers. So 0.2, 0.1. All right. 0.3. That looks fine. I mean, to me, these are looking like it's not shorted or anything like that. It's not infinite resistance. I mean, I would think that these are looking okay. That's the heater voltage. Pair, 4 and 5, and then 3 and 1. They all look about the same. Alright, so that's our resistance test on the windings. I can't do it, I think, let me see. Can I get a reading from here to pin 2 or anything? No. Nothing from the anode to any of these suckers. Anode to focus. Nothing. Focus to anything. I mean, it might be going to something else, you know what I mean? It might be going to one of these other holes that's basically filled in with epoxy, so I might not be able to even get to that. And I think that's the same. I'll just double check. Oh, that's interesting. That's what the inside of that cap looks like. Basically the same. Alright, so let me do that. To pin 2. Nothing. Nothing. And I'm sure it's the same with the focus. So that's all I can check is the pins down here with the resistance measurement. So then I have this ringer test on my CM2125, and I've never used it before. And basically, I'll link to somebody else's video. I'm not going to be able to explain this, but basically it sends out some type of frequency and it measures how many, like the inductance or something. I don't know. I don't know exactly how the ringer test works, but it's sending out a pulse. And then it basically measures how many pulses it gets. And so there was a guy who did, for a different brand, did something. I'll link to his video. And so you'll see it like go smaller and smaller and smaller and smaller and smaller, like that, kind of. That's my bad way of describing it. So what we do is we ring out the different parts of the transformer. So we have the primary winding side, we have the secondary winding, and we can do a ringer test. Now, anything bigger than or greater than 10 is supposed to be fine. I don't know how the Sencore says 10 is good. But on our bad transformer, let's go between 6 and 10. Okay, on our ringer test. And then, what do we get? Oh, the glare is bad, but you can see 10 rings. It says it's good. Right? But really what you have to do, and sorry for the camera movement there, is you have to compare it to something else. So is 10 really good? Well, let's go to the Bob Roberts one between 6 and 10, which is the primary side. 37 rings, which I assume is a lot better. Alright. And then let's go to, whoops, crap. Let's go to what I'm calling Peter's Flyback. 6 and 10. 63 rings, which is obviously the higher the number is probably the better, but it also I think has to do with if there is something shorted on the secondary side, it's going to cause a problem on the primary side. That's kind of my understanding based off my very basic research, like of 1 hour this morning or 2 hours or something. So I'm thinking that this Flyback, even though there's no visible signs of it being bad, is either it was designed completely differently than these new ones, or it is bad. I don't know. I mean, we're measuring it and comparing it here. And I'll pause and let's take some more measurements. We're going to go from 6 to 7. $42 rings on Peter's. You can see that. 43 rings. Okay. Gotta use both hands here, so forgive all the camera movement. On Bob's between 6 and 7. 16 rings. 7 rings. So you expect it to, it shouldn't be necessarily, you know, half, because it's not truly a center tap, I don't think. But it definitely should be less than what 6 to 10 is. Now this one was 6 to 10 was, what, 10 rings on the bad one. And now we get 15 rings. Now that makes no sense. Why am I getting more rings on 6 to 7 than on 6 to 10? That is kind of, again, leading me to think that that might be whacked out bad. Let's go 7 to 10. Alright, I'm getting about 11 rings. Again, apologize for all the camera movement. And we'll just do a reference to both of these other ones. 7 to 10. I'll just tell you. That's 30 rings. 30, 36, 35 rings. 35 rings. And this is a cheap, you know, I didn't buy, this is not a Sencore cable or anything. This is just something very simple. On Peter's, what I think is, you know, a better Flyback, 62 rings between 7 and 10. Okay, let's go to our heater, which is 4 and 5. I'll show you on Peter's, 21 rings. 21 rings on, I'm just calling it the Bob Flyback. I don't know if it is Bob. Sorry if I'm attributing that incorrectly. It says it's bad. 8 rings. But maybe there's not a lot of coil or wire between those. So maybe 8 is not really that bad. Honestly. Just means that I think there's just less, you know, turns of the coil. Now on the other transformer, the questionable one, 3 rings. 3 rings on my questionable transformer. Alright, I know this is kind of boring. I'm just documenting, so if anybody has to do this, they see what exactly readings I'm getting. We'll go from pin 3 to pin 1 on the bad transformer. I get 12 rings or 11 rings on the bad with my CM2125. On the Bob, 18, 19. See, still going. 19 rings. And I will link to somebody else's video because he kind of showed the Ringer test on the oscilloscope as well. And that is kind of interesting, but I'm not going to do that in this video. On the Peter transformer, 49 rings. between 1 and 3. So we went from like a lot of rings, kind of middle of the road rings, to rings very low. So let me come back. I have one more transformer that we have, and I might even write it down to document it over here. One more transformer, because I actually have 3 G07 chassis that are all screwed up that have potentially bad flybacks. Okay, so I did break this down, so I know you might not be able to read it, but 6 and 7, suspect 1 is 15 rings, Bob's is 17, 6 to 10, 10 rings on the suspect one, 39 on Bob's, 66 on Arcade Parts and Repair. Again, I'm not sure where I bought these from. I'm just making some assumptions because I think I'm right though. So I grabbed this one. This one came out, also has the fuse 901 blown, but it came out of one that was like a rat's nest. There was like, you can see like mice or something like were chewing up the plastic and oh, I just lost that. I can save that. So this one is also suspect, I would say, but it is an original Flyback. So real quick, we're just going to measure. Oops, let me flip it around like this. We're going to go 6 and 7. And that is still moving, 24 rings. Alright, then 6 to 10. $37 rings. Alright, and then 7 to 10. $37 rings. This one's definitely looking better than suspect. This one, the first suspect one. Heaters 4 and 5. About 8 rings. 10 rings. Even better than Bob's. I assume more is better. That's an educated guess. 3 to 1, which I'm not exactly sure what that's for, what that's powering on the schematic, is 27. So, I mean, this thing seems like it's probably good. Again, no indications, visible indications of this being bad. Now, it is been chewed up, the wires and stuff, but maybe this is still a good transformer. Not sure. And I think I have one more left that's actually on the G07 tube that I want to test. So okay, so that's my ring test. I'm going to go ahead and pull our hot transistor on this chassis. I'm going to put in a new Flyback. We're going to test the hot transistor, replace the fuse, and hopefully get this thing working. Alright, so I have everything ready, and I don't even know where to start here, but basically I have a replacement hot here, which I assume is good, and I tested it against some other ones, and I think it's good. But these transistors are, I don't believe they're like regular NPNs, because I drew out this schematic here, and you have your base, and then there's like an internal resistor between the base and the emitter, and then there's a diode between the collector and the emitter, and then you have your normal kind of NPN not pointing in between the collector, base, and emitter. So the way you can test this, or the way I figured I would test it, let me see here, kind of move it to the side a little bit, there we go, is we will go to resistance first, and just go between the base and emitter, and we should get about 50 ohms. As you can see, it was like 45. And then we'll go to our diode test, and we will go base to collector, and we should get a voltage drop of about 0.4 there. And then emitter to collector, what did just happen? I don't know. Emitter to collector, voltage drop. And so you won't get a voltage drop between base and emitter, but you will between emitter and collector, and base and emitter. No, and base and collector. And then you shouldn't get anything from collector to emitter. And then obviously 50 ohms between there. So I wrote it all down right over here. You can see that. Alright, so basically I just desoldered, instead of removing the whole the horizontal output transistor from the frame, I just desoldered the emitter and base. And I think this is going to be easier going forward because I've done it the other way and it kind of sucks. This just seems pretty easy just to desolder these two pins. But to test it in circuit, what I think I need to do is see if it's shorted, and it's not. The collector to the frame is not shorted. And then I can go red on the collector, which is S1. And then see what I get here. Well, let me go to my diode. Should be over limit to both the base and emitter. This is base, this is emitter. And so then I should get 50 ohms between them. I get 44 ohms, so that's good. And then I should get from, let's see, base to collector, voltage drop, emitter to collector, voltage drop, and I think that's it, right? Base to collector, voltage drop, base to emitter, 50 ohms, emitter to base, 50 ohms, emitter to collector, voltage drop, and then over limit the other way. So I think this hot is fine. I'm not going to replace it. So I just need to solder this back in. I got the fuse in, and we're going to power up this chassis. So, and then we'll probably test another one. We'll see. All right, I have everything hooked back up, soldered in. I think I got everything right. And I'm zoomed in on that. Whoops! I'm zoomed in on that transistor. I'm going to turn off the lights and power up, I guess. Whoop, I hear high voltage. That's good news. Let me turn on my TPG, turn the lights on. My TPG is on. Bam! Oh, I'm zoomed in. Working. Obviously that was a bad flyback. Focus works. Screen adjust works. Alright, so how many? I don't have much time. I think that's all I'm going to do with this video. Tested the flyback. I don't know how long it is. And got a working chassis, and I'm going to come back and do a different video on measuring some voltages on this neck board, because that's why I actually started down this G07. There's a comment on Clove, and I wanted to go do some experimenting. So I'll be back with another video after this. Thanks guys, that's all. Working monitor, bad flyback, good hot.